Hey, Assalamualaikum. Good afternoon, good morning. Sound check, clear? All right. So last 2 days, you've been introduced to two settings of the current relay. First one being the current setting. So current setting, basically what you do is you is related to this, right? And then for the other one is the time setting. The time setting, it is when you deal with the fault current. Okay. Yeah. And you start by setting the relay furthest downstream away from the source here. Okay, and work towards the source. You have a lot of freedom when setting this downstream relay, yang paling ujung. But as you move upwards toward the source, the setting of the relay must be set to back up the lower relay. Okay? This goes here, this goes here, and this, of course, yeah. So that's the essential point. So what we're going to do today is basically the same thing. I'm just going to share you a different configuration of the networks. So before this, you see, it's just a feeder, a cable. But now I'm going to introduce you transformer in the circuit, okay, as shown in the figure here. All right. So you have 11415 transformer here with CT ratio given at both side of the transformer and also the CT ratio at the feeder downstream of the transformer. Okay, max load at its feeder of the 415 volt bus. This is 415 volt bus here. So maximum current is going to be 750, 750, and so on. So basically, you're going to have the same setting for these three relays, provided that you have the same ratio for the CT. This is usually the case when you design a system. Basically, you decide on the maximum current here. You normally design the same thing. Okay, maybe for there might be some other cases where the feeder is supplying more current. Okay, maybe for motors. Okay, this one is for AC, lighting, and so on. Okay, so you can normally assume that everything is the same here. Okay, the ratio of CT, of course, we have different ratio here because here on the HV side, okay, you have lower current, and on the LV side, you have higher current. Okay, right. So max load is there, of course, as you simply take the value of the CT closest to that value, 800 to 5. But then again, as for the CT, you need to consider this as well. Right? For current is 23.6 A. How many times the rated current of the CT? So the accuracy limit factor must be considered. Okay, let's assume that. I mean, let's skip that for this example. We're just going to focus on the setting of the relay. Okay, fault occurs at near C. Yeah, here giving the current of 23.68 kilo amp. And this relay should respond within 0.25 seconds. And for relay B, you have to add another 0.4 second delay. Both relay A, B will operate simultaneously. It doesn't matter because, from the previous example, B is backing up C, A is backing up B, but, well, you can have another relay here backing up these two. But since this transformer on both sides, it basically, if one trip, it can also trip the other one. Okay. In any cases, the transformer is not going to be there. Not to be supplied with current. Okay, you isolate this part, the transformer doesn't work. You isolate this part, doesn't work as well. Okay, so can be designed to have similar operating time. Meaning that there might be some slight variation, but we'll see later. But it's okay for A not to be backing up B. Okay, now at C, we continue to set the relay as usual. First of course, is on the current setting. Okay, these are the information that we have. Okay, waiting time is given. So from the equation of the plug setting, it should be greater than 93.75. So you take the closest one. Let's just assume the closest one is 100. Okay. Of course, it should be provided in detail in the example. Just not really class to here. Okay. So plug setting is 100. By taking it to be 100, the relay setting current will be 100% of this, 800 ampere, which is greater than the maximum load and without considering the errors. This should be okay. All right. Similar to the previous one, when we proceed to the setting of time setting. Okay. Of course, for time setting, you need to identify the fault current and the relay setting current here. Current is here. Happen to be 29.6. Right? But you cannot simply use the equation. For example, if it is a standard inverse 0.14, hold on, Sekarang saya kena jawab phone ni. Okay, sorry about that. Well, you cannot simply use that in the equation. PSM to the power of 0.102 minus 1. Because this is the equation for the inverse part. But the inverse does not extend until to 29.6. Okay. Okay, normally starting from, okay, this is the curve. Normally start from the relay setting current here, which is PSM equal to 1. This is 1. Normally up to 20, 22, 1, 22, depending on the manufacturer. Okay, that is the maximum value. So when it reached this point, it is a flat line here, meaning to say the operating time here is equal to here. You can simply put 20 here in the equation. 20, or in this case, depends on the specification given. Maximum value of TSM is what? Okay, so be careful on that. So there's one additional things I have introduced you. In the previous example is kind of straightforward, but now I've introduced you this, right? As well as of course the transformer. So for that reason, you take it to be 21 and plug into the equation. You have this 2.2 seconds, right? So jadi okay. Now TSM apa ni? RCOT is there, and then salah juga So RCOT is 2.2 seconds. The TSM that is, the operating time that is required is this 0.25. Therefore, you need to set your TSM according to this requirement. Okay, you cannot simply put the fastest setting. Okay, fastest setting will of course give you the fastest operation time, but in this particular case, the operation time has been specified 0.25 seconds. So TSM is set as 0.11. Okay, that's the first part. Okay, really see, paling ujung, no problem. Now, we are moving to the transformer. Of course, will be on this side first, the LV side. Maximum load of the transformer is basically the transformer rating. It is rated at 1 MVA with the voltage level of 415 on the LV side. The maximum current is 1391 ampere. Heat ratio has been selected. The fault current remains the same. Okay, fault current here 23680. It is seen by this relay as well, this relay B. But the operation time, since this is backing up C, so there will be a discrimination time of 0.4 given in the question. The operating time for that particular current is 0.65 seconds. Okay, so plug setting, you're using this equation greater than this value. The closest one is 100. You take that 100, therefore the relay setting current will be 1600. Right. Compare to this. Any observation? Anyone want to comment on that? The relay will trip at the current of 1600. Maximum rating of the transformer is that is 1391. Any comment? Comment. This is the maximum. If the current exceed that, maybe 1500 greater than this, will the relay trip? Senyap dia tak apa. But if you notice that the relay will not trip even though the current exceeds that. All right. We take it to be less than that, so 75%. So it will trip at 1200. That's the question. Okay. So, well, you can have this, but by having this, you are not able to use the transformer up to maximum capacity. It can go to this value, but it is limited at this. Okay, fine, no problem. That's one of the good practice. But there might be some time where you might want to allow an overload of the transformer. So even though the maximum is rated at 1391, you might need to operate up to this value, allow some extra margin. But of course, this should not be a continuous operation. Okay, you can allow overload for a little bit. So for that reason, I mean, you can use this equation, okay, greater than. But then again, it is your transformer. You know the operation of your substation, your load and everything, the standards to be used, the guideline. So you decide whether you have a whatever setting that is suitable for you. Okay, transformer sendiri lah. So you not allow for overload or not. Of course, I mentioned that the overload should not be continuous, but if it happen to be continuous, this is not going to protect the transformer. Okay, not going to protect your transformer, but you have additional protection systems, especially for the transformer itself. So this is in a way a backup for that. Okay, the main function of this protection system is not to protect overload, it is to protect against fault current, which is of this value. Okay, so take note on that. So for consistency in this class, we simply use this equation, but there's no harm using PS if less than that. But I would advise against that lah, for the sake of consistency in this class. All right. So you have this 1600 fault current divided with your RSI. This is your QSM. Plug into the equation. Your OT is 2.5 seconds. The requirement is 0.65. So you have to set your TSM to this value, 0.26. Yeah. Okay. 0.26. Mana dulu? What happened? Okay, clear. Now we move to the other side, to the LV side. Sorry, to HV side. So on the HV side, uh, it follows the same step, but the difference is that you need to consider this. Voltage on the HV side, 11 kV. So for this value, the rated current on the HV side is 52. The ratio is given. Okay, settle. But you are backing up the current on this side, LV side. So that amount of current coming from this is not going to be of the same value on the HV and LV side. So there's a ratio there, kena kira lah. So the fault current is 23.68 kilo on the LV side. So, but on the LV, HV side is going to be of this value, right? So you're going to use this. Do not forget this. Okay. Operation time is still you're backing up. A is backing up C, which operate at 0.25, so it's going to be 0.65. Find the plug setting, use this equation, 75% of that 75, it is going to be 56.25. Again, we are having the issue of allowing for some overload. That is your judgment. Okay, so the only difference here is this. Okay, fault on different side of the transformer. Sorry, fault measured from two different side of the transformer. Is going to be involving this ratio. Okay, PSM is simply the fault current, put nicely there against whatever the setting of the below setting current. RCOT is 2.5, but the requirement is 0.65, so you set your TSM accordingly. All right. So that ends the example 2. I guess if you don't have any question, we can proceed with the second one, the third example. Okay. So far, in this example, two things have been introduced. Number one being the maximum value of your PSM. So that translates to your fixed RCOT. Another thing is on the transformer ratio. Okay. So these are the two things that are being introduced in this example. Let's move again. RCOT. Well, the equation is 0.14 PSM to the power of 0.02 minus 1. It's not shown in the slide. Write it somewhere. Okay. It's going to be given to you, whether this equation or some other equation. Okay. So in this, okay. Uh, okay, welcome. Anything else? Okay. Now, example 3 is more comprehensive. Okay. Complicated, but not, I mean, it is manageable. You see what we have: one, two, three, four levels. The presence of transformer. So with the presence of transformer, you need to be, I mean, to consider the ratio. And here the loads are given in MVA, not in ampere. CT ratio has been given there. All right. Is your network. What are the specifications of what are you required to do? You need to propose the relay setting using the nearest value of setting and TSM for all the relays. The specification of the relay is given here. Plug setting between 50 to 200 instead of 25. So you have this 50, 75, 100, 125, 150, 170, and 200. TSM is from 0.01 to 1 instead of 0.001. And you see, if you calculated it to be, I mean, 0.012, that thing is not possible. You need to round up or round down. That's the question. Okay, so this should be 0.01 or should it be 0.02? Okay, for you to ponder. Then you need to consider the errors and so on. Discrimination time as well. Okay, discrimination time is if the PSM value is more than 21, what is the PSM value you should use? Okay, if it is PSM value is more than 21, okay, look at the relay specification. The equation for RCOT is 0.1. I'm taking the example of standard inverse. It is the same PSM. to the power of 0.02 minus 1. Now, you should look at the relay specification. What is the value here? Is it 20, 21, 22? These are typical value. Okay, in this previous example, use 21. All right, it becomes flat here. If you calculate it to be, let's say 30 this here, right? The equation is for this region. It is flat. So at this point, let's say it is 20. At 20, the operation time is going to be this. You put on RCOT equal to 0.14 20 to the power of 0.02 minus 1. Okay, you take that maximum value, be it 20, 21, or 22, and so on. Because, I mean, if it is greater than that, the time is the same here. Right. Kalau pakai graph mungkin tak nak itu construct apa. You're not going to have this silly mistake. But remember, this equation is defined between 1 to 20, for example. That's maximum value of PSM. Okay, does that answer your question? All right. Okay. Let's continue with this. Assume that the relays 1, 2, 3 will operate with 0.3 second when three-phase fault occurs downstream close to the relay. 6 with 0.22 second. Okay, why it is 1, 2, 3, and 6? This is because this is the furthest one downstream, paling ujung. And also 6. Even though it is at the different voltage level, but coming from the source, fault current goes to, yeah, ini paling ujung. Kalau ikut root atas, so these are the furthest. Use standard inverse IDMT relay characteristic, basically this equation. All impedance values are referred to its own rating, blah, 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 and so on. Okay, it seems that you are having this in terms of MVA. Recall in the previous example, you need ampere. And also fault current is not given. If fault current is not given here, you need to do the fault analysis. Yeah. Right? But let's, okay, fault analysis, we skip first. We'll just do this. Okay. The voltage level are given there. The equations are there. CT ratios are there. So first of all, we start with the current setting. This is straightforward, kind of straightforward, because you can do them independently. The setting of relay 2 is not related to R3, not related to R4. It's simply, you're simply looking at the current that goes, okay, the maximum current, nominal current that goes through the relay. Okay, so in this case, for relay 1, the maximum load is over 2 MVA here. You convert for this, it's 3 and then 4. You convert that into current simply by, if you're familiar with this equation, right? Over I equal to 2 MVA, set 3 multiplied by 13.2 kV. Okay, do not forget this. This is three-phase system. You have this current. Okay, a little bit of additional work there. And you can go on calculate for the remaining two relays. Okay, settle for this level. Next, we go to this R4. So R4 is supplying current to R3 plus R2 plus R1. So basically, you need to add them both. Okay. Or perhaps the cable rating can be used as well, but not covered in this class. So for really four, then this section of the feeder is carrying 9 MVA. Using the same equation, you can have a 393.65. Or, okay, using this equation, or perhaps you can tambah semua ni. All right, now we move to relay 5. So the maximum current here, I mean, this is just one branch. All right, dia tak ada pecah ke mana-mana. So KCL indicates that the current is going to be here. If I put ammeter here, it's going to be 393.65. But the relay is at the HV side, ratio should be considered as well. But, I mean, this is coming from 9 MVA. But the transformer is rated at 10 MVA. So you don't normally use this 9 as a value, you use this 10 MVA rating of the transformer. Because you don't want to, I mean, if you set it at 9, you are limiting the capacity, the utilization of the full capacity of the transformer. So that's the tax rating. Okay. Maybe in future, if you want to add another feeder here with a capacity of 1 MVA, it can be. The transformer can handle that, and you don't have to do resetting of the of this relay. Otherwise, if you're making this according to 9 here, it becomes 9 here. But when it comes additional 1, it has become 10. So you need to redo the setting. So that's why you have your rating of the transformer as the value taken here. Of course, it is going to be calculated using this formula 167. This is on the HV side. This is LV. All are LV. The same goes to relay switch, straightforward, because it's just two using this equation, but with different voltage level, 34.5, you have 33.47, and it comes back to something similar with R4. Okay, tengok kat bawah ada berapa, you total them up. So R7, you total R5 and R6. Okay, 10 and 2 here comes 12, and so on. 200. Okay, so once you have converted all the MVAs, add them if it is required, you can have that ampere. And the next part will be simply setting up, determining the setting of your RSI. Okay, so CT ratio berapa, plug setting berapa. So plug setting is going to be greater than 37.48 divided by is 200 multiplied by 100. Okay, it's been solved for you. I'm not sure whether you have that value in your slide. Okay, check your calculation against this value. Okay, relay setting currents on the which is going to be greater than this. Okay, this is greater than this. Greater than this. Again, this is transformer. Whether it is greater and lower than this depends on your justification. Okay, to allow overload or not, and so on. Okay, so that was the first part. You normally can do this very easily. Most of you guys will have full mark on this. Yang tak dapat tu dia melata kat sini, I mean, and this. Normally this transformer rating. You don't have to add everything downstream. You just simply use the rating of the transformer. Okay, so that is the first part of the setting. Of course, here some data needs to be processed. Okay, converting from NVA to maximum load current. The next part is on the current setting. It's going to be very long, but fault current is not given, so you are required to do some fault analysis. Simply using a per unit and Thevenin equivalent impedance senang dia. So I'm going to show you this example. Apa benda ni? I mean, you have this. One, impedance of the source, impedance of the transformer, impedance of the line. So if I were to redraw that, open circuit here, this is your generator, this is ground. Okay, this is Z source of transformer, and then, Z source, Z transformer, and Z transmission line. But they are not given in a common base. Apa je soalan yang kata tadi? Impedance on transmission lines 1.5 base 100. 13.2. 1.5 base 100, 13.2. Okay. 1.5 base 100 MVA, 13.2 kV. But now you have this transformer. Okay. It is 0.2, but rated at 10 MVA. So old MVA, new MVA, you have this. Old per unit multiplied by new MVA over old per unit, you have 2. Black line, you don't have to convert that. It's 2 here, 2 here. But on the source side, okay, you need to determine your source impedance. This is the formula for that. And the base impedance is, well, by definition, is the rated voltage square over MVA is pretty much the same thing. So if the rating of, the base is similar with the rating of your source here, is going to be 1 per unit. Okay? So, macam mana nak kira? Then we need to do 3 cases. 1, 2, another 3. This is transmission line, transformer, this is source. For R1, 2, and R3 is going to be here. So fault current is going to be 1 over base impedance, 1 per unit, plus 2 per unit, plus 1.5. You have that current, and the actual value will be this. For R4 it is here. So it is just 1 plus 2, 0.33. Converted to actual value is going to be 1458. This is on the secondary side of the transformer. You can find the one on the primary side by using this voltage on the primary side, or even multiplied by the ratio. Apa darah apa 13.2 over 34.5. Same answer. And for this, you have this. Right. Now, So you have this 972. Here it is 1456 972. Then here it's 1673. 1673. 70. Now, for relay 1 to 3, yang ni paling ujung tak ada masalah. For, I mean, eh, relay 4 downstream is 972. Okay. But for R5, the fault current is 1673. Fault occurs here. But you are backing up this R4, which is 1458. But that fault is on the secondary side. Converted to the primary side, you have this value. And the rest is kind of straightforward. Now, you might be wondering, because I want to set relay 1, right? So relay 1 is covering for fault. Right? Let's say this is a very long feeder. Can be here, can be here. But the maximum value is just right before the relay. Okay, 5 faults. But in order to set relay 1, what I did was I do the fault analysis at the bus bar. Why is that so? Might be wondering, because if fault occurs here, it's not going to be seen by this relay because it's on the other side. The relay is looking in that direction to the right. Okay. The reason being is that, well, it is effectively the same point. Okay. It is, if you consider a bus bar there, you have cables connected to this, this. And then there's another cable connected to the other side of the bus bar. So you put on your CT here. Put on the CT here. Port to the right will be detected. Okay. To the left will not be detected. Okay. It is looking in that direction. But this is basically just one point. Different side of a connector. So we don't actually measure the impedance here from here to here. Okay, this is 1.5, 1.5. But from this to this is more or less 0. So that's why you do fault analysis on the other side of the relay, which is at the bus. We do fault analysis on the bus anyway because of, well, we have parameters. This transfer impedance. I mean, this impedance here between buses. We have Z between bus A and B. So that's why we do fault analysis on this. So effectively the same. Okay. So you have all the fault current there. Okay. The next step will be on the time setting. So I'm going to skip that for today. We're almost at the end of this class. If you don't have any question, we can stop it here. Ada apa-apa nak tanya tak? So, in this example, there are some new things. First of all, you need to convert MVA to ampere. The second one is you need to do the fault analysis. Okay. Of course, this fault analysis part is not going to be apa I mean, this is just a refresher punya equation from previous one. 4423 4443 or system analysis. Well, it can even goes back to your circuit analysis. Very straightforward for unit and so on. Okay, so these things are the new thing. on top of the previous presence of transformer, and also, of course, the characteristic of the relay. Okay, the presence of transformer is indicated here. Port here, 1458. If you measure it here, it's going to be 558. Okay, kalau tak ada apa-apa, saya stop dulu di sini. Dan the next is your attendance. Uh, okay, then betul. Oi, pelajar section 2, section 4. Salah, asal ada je. Yang bestnya boleh keluar room
Doktor, saya tak dapat scan.
Sebelum ni tak dapat scan juga
Saya section 4.
Nampak, tak dapat scan.
Sekejap
Okey,
Okey dah.
selamat hari raya, maaf zahir batin. Selamat bercuti.
Selamat Hari
Allah,
Raya,
baru nak
Doktor.